Hi you guys. So today's video is about parallel and perpendicular lines again. It's our second 4.3 video. And so the other day we were trying to write equations of parallel and perpendicular lines. Today we're trying to compare and determine if two lines that you've been given are parallel, perpendicular, or neither. Okay, so the way we do this is by comparing the slopes. All right, we got to compare the slopes, right? And we're looking for those relationships we talked about yesterday. So if we have two lines that have equal slopes, we know that the lines are going to be parallel. Okay, if their slopes are the same, then the lines are parallel. If the slopes are opposite reciprocals, then we know that the lines are perpendicular. And if it's neither of those, the slopes aren't the same, and they aren't opposite reciprocals, then the lines are neither perpendicular or parallel. Right? So sometimes we'll be given a graph, sometimes we'll be given equations. So in these first problems, we're given two equations. So number one are the lines y equals 3x minus 4 and negative 2x minus 6y equals 18 parallel, perpendicular, or neither. Okay, so what we want to do is we want to maybe call this first equation equation A and the second one equation B, and we want to try to find the slope of each. So the slope of A, m of A, that's in slope-intercept form, so it's just 3. Okay, to find m of B, I need to convert that equation. So anytime the equation is not in slope-intercept form, but we need to find the slope, we're going to have to solve it for y so we can get it to look like slope-intercept form, like this one, like A. Okay, so in that equation, I'll add 2x to both sides. So I get negative 6y equals 2x plus 18. And then I divide by negative 6. So I get y equals negative, and then reduce that 1/3 x minus 3. So my slope of b is negative 1/3. And then my job is to decide, are they the same? Well, clearly they're not the same. Are they opposite reciprocals? Let's see. Positive 3 and negative, so they are opposites. And 3 and 1/3, they are reciprocals. So these are opposite reciprocals. So we'll say opposite reciprocals, which means the lines are perpendicular. Okay, so if we graphed these, they would form a right angle. Let's do another. In number 2, we're comparing the lines y equals 4/3 x minus 4 and 4y equals 3x plus 5. Are they parallel, perpendicular, or neither? So let's do this again. Let's call the first line A. Let's call the second line B. All right, line A is already in slope-intercept form, so I know that the slope of A equals 4/3. B, I'm going to have to compare. So B is not in slope-intercept form. I got to divide by 4. Y equals 3/4 x plus 5/4. So my slope of B is 3/4. Okay. If they were parallel, they would be the same number, and they're not, so it's not parallel. They're not opposite reciprocals, because this is positive and this is positive, so that opposite part is not there. They are reciprocals, but they're not opposite reciprocals, so they can't be perpendicular either, which means these lines are neither. Neither. Okay. All right. Number 3. This time we're not given an equation, we're actually given a graph of two different lines. And the question says, are the lines parallel? Well, just looking at them, it seems like they could be. They kind of look like railroad tracks. How are we going to know for sure? We've got to check the slopes. Okay. When you have a graph, sure, we could call these points, we could label the points, but I'm just going to check for rise over run. So again, I want to label them A and B. So my slope of A is rise over run. So I'm going to count the rise. I go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. So 6 over 6, my slope is 1. Let's check B. My rise is 1, 2, 3, 4, 5, 6, and my run is 1, 2, 3, 4, 5, 6, 7. So my slope of B is rise of 6, run of 7. Those are not equal. So these are not parallel lines. They're clearly not perpendicular either, so these are neither. But the question says, are they parallel? So the answer is no. All right, how about these lines? Are they perpendicular? They're definitely not parallel because they cross, but perpendicular means do they cross at a right angle? So we got to check their slopes. I'll call the red one line A and the purple one line B. So my slope of A, again, just do rise over run. We could find points and use the formula, but when you have the graph, it's easier to just count boxes. So I'll start down here in the bottom left of red and go up 1, 2, 3. Rise is 3. Run is over 1, 2. So my slope of A is 3/2. And then the slope of B, let's see, I'll start away up here in the top left, goes down 1, 2, so -2 over, run is 1, 2, 3. And then we got to decide what's the relationship between those two slopes. Are they opposite reciprocals? One's positive, one's negative, and they are flipped over from each other. So these are, woohoo! Now we've got perpendicular lines. So yes, perpendicular. Okay, one more problem. Here, let's see, this is problem 5, I think. Which line is the line y equals 3 parallel to, and which one is it perpendicular to? And your options here are x equals -2 and y equals 5. Okay, so I want to know y equals 3 is parallel to and perpendicular to. Well, there's a lot of different ways we can think about this, all right? My favorite way, and I think the way that I really want to make sure you guys understand, is that y equals 3, we should know that that's a horizontal line now. Its slope is 0. Okay, so if I were to graph it, I would go up to 1, 2, 3, and draw this horizontal line. Remember, we used to make the charts where the y value was always 3, so you could pick another point where the y value is 3, let's say. Okay, so I want to know which line is parallel to that line. Well, it would be another y equals line, like y equals 5. I could go up to 5 and make a horizontal line there. So both the y equals equations are horizontal, which means that they are parallel. So y equals 5 is parallel to y equals 3. If I graphed x equals -2, right, I would go x equals -2 is a vertical line. I go to -2 and I pick another point where the x value is -2, and now I graph that, which means that line is perpendicular to y equals 3. So equations that are just x equals a number and y equals a number are perpendicular to each other. If you have two equations that are both x equals or both y equals, they're parallel. Okay, thanks for watching.